Welcome back to my YouTube channel. In today's video, I'm going to be solving a question in which I'm going to be using 2 to 3 different formulas. And the question is a physics-based question. So let's take a look at this question. But before then, I would like to beg you all to please click that subscribe button, the share button, and the like button. It's a way of supporting us, encouraging us, and telling us that you love what we are doing and want us to keep up the good work. The question says a working electrical motor takes a current of 1.5 amps when the potential difference across it is 250 volts. If the efficiency is 80, the power output is. Now, I'm sorry that I did not put that potential difference in full. I'm sorry I put it as PD, but that is potential difference for those that don't know about it. Now, the funniest thing about this question is it is tricky, but yet this question still came with option. Now let's have a look at this option. Option A 300 watts, option B 469 watts, option C 133 watts, option D 4.8 watts. Now some of us may solve this question anyhow and be arriving at any of these options that is not correct. Out of this option, only one is the right answer. But there are ways in which you solve this question, in which you will either get A, B, C, D, or D. You can solve this in one way and get A. So another person can solve it another way and get B. Another person can solve it another way and get C. So on like that. But there's only one right way to this question and only one right answer to this question. Now let's write out what the parameters give. We're given our efficiency of the electric motor to be 80%, the current that is represented as I to be 1.5 amps, and the volt which is represented as V to be 250 volts. Now, rather than not stressing ourselves, since we are given efficiency, why don't we look for a formula that relates efficiency to the power output? Now, efficiency is given as power output over power input times 100. But in this formula, there are more than one unknown parameters because we don't know our power output and we don't know our power input. But if you go back to this question, you will notice that all the parameters given, that means the voltage, the current, is related to, or is what you can use to get the power input, not the power output. Because input is what you put into the system. That means yes. Then output is what is known as a result. That's the layman explanation in my own term. It's not part of it, it's just in my own term for you to understand. And formula for power is equals to IV. Then if I solve for power using I and V, that means these parameters I'm giving, I'm going to get power input, not power output. But since I already have a formula that is efficiency is equals to power output over input times 100, then it can go for me. Because once I get my power input, it will only remain power output or as the unknown parameters, and that's what I'm looking for. So let's solve power input first. So power input is equals to what? IV, that's equals to 1.5 times 250, and that will give me what? 375 watts. Now I'm one step close to the answer for this question. Okay, so let's try and make this power output stand alone. Now first thing I need to do is cross multiply. Yes, so if I cross multiply, it's going to give me efficiency times power input is equal to power output times 100. I can either decide in this case to make my power output stand alone before inserting my parameters, or start inserting parameters from this place. But for me to make this video easy to understand, I'm going to start inserting my parameters from this place. So that will give me what? Efficiency, that is 80 times power input, that's 375 is equals to power output times 100. 80 times 375 is going to give me what? 30,000. That's 30,000 is equals to what? Power output times 100. Now, I want to make power output stand alone. Since I've simplified the expression from that beginning to this case, Now it's now time for me to make power output stand alone. And for me to do that, I have to divide both sides by what? By the coefficient of what? Power output. And in this case, the coefficient of what? Power output is what? Is 100. I know some of you may not understand it, but that is the best way to explain it. So that is going to give me what? 30,000 over 100 is equal to what? Power output times 100 over 100. 100 over 100 will cancel out each other. Now, sorry, power output times 100 over 100. That 100 that is the numerator and the 100 that is the denominator will cancel out each other. And that will give me what? Power output is equal to 30,000 over 100. 30,000 over 100 can further be simplified to what? 300. So my power output in this question is what? Is equal to 300. And don't forget the SI unit, which is watt. So power output is what? 300 watts. Thank you for sticking along with me to the end of this video. Please do well to click that subscribe button and do well to like, share and comment. Please make sure you comment and like. It is very important for the growth of this channel. Bye for now.